So in this particular average speed, average velocity problem, you have a cow moving in a two-dimensional grid. It's shown from top view, aka bird's eye view. All right, so let's go ahead and get to it. Part A asks us to find the average speed. Part B asks us to find the cow's average velocity. So this particular problem is trying to teach you the differential between the two quantities, average speed and average velocity, based on physics definition. So pay attention closely. All right, so it looks like the cow is going to travel 35 meters east, and that's going to take a time of 50 seconds in red there. It's going to turn north 20 meters, and then that's going to take 40 seconds, and it's going to turn west, which is for a distance of 12 meters shown there, and then that's going to take 16 seconds, and then it's going to turn south for a distance of 6 meters, and that is going to take 10 seconds. All right, so let's go ahead and attack part A. To do part A, pretty straightforward. Average speed equals distance over time. What distance, what time? Total distance over total time here. So to find the total distance, we would simply add up all the distance given in the schematic. Again, it's 35 meters for the first leg, 20 meters for the second leg, 12 meters for the third leg, and then 6 meters here for the fourth leg. We would just add up those values. You don't really care if it's positive or negative because distance is a scalar quantity. So just add each of the steps taken regardless of direction. So here in my numerator, I have 35 meters plus 20 plus 12 plus 6. And then in the denominator, all the times were given in the schematic. The first segment took 50 seconds, the second segment took 40, the third segment took 16 seconds, and then the fourth segment took 10 seconds. So that's where all those values come from. So we simplify here. The numerator is going to give us 73 meters, and then if we add up all the times up in the denominator, that's going to give us 116 seconds. And then punching this in our calculator, that'll give us a value of 0.63 meters per second. Average speed is a scalar quantity, so there's no need to include any sort of direction at all, okay? So keep those things in mind. All right, let's go ahead and do part B, which is a little harder here. So to do part B, we would just apply the physics definition of average velocity. By definition, average velocity is displacement, which is delta x here, over change in time. Displacement is how far you've been displaced from your original location, which in this case would just be a straight line. All right, so to find this displacement here, where the cow started, I just drew an arrow to where it finished. And we notice here we have a diagonal. So this black arrow must have components. We must find the length of this particular triangle. To find the length, I've shown you here. So the first leg in the horizontal direction is 35 meters. Okay, and then we notice in the diagram in purple, the cow turned left or went west for 12 meters. So I did that. Okay, here's 12. So really, how far in the horizontal direction did the cow displace itself? So the difference here in this case would be a 23 meters, but it's got to be pointing right because this diagonal is pointing right and up. So I filled out here the leg is 23 meters, and you notice here the leg is pointing to the right, okay? And we can use the same strategy to find the height of the triangle. In this case, that'll be pointing north, and that length is 14. So if you look at the schematic here in blue, we have an arrow pointing upward in the north direction. That is 20, but then the green arrow is pointing south, which is 6. But if you really think about it, starting from where it started, it's actually 14 meters north of where it started. Okay, so 20 minus 6 is 14. It's north because the arrow is still pointing straight up in the north direction. So that's 14. So you notice here, we need to do Pythagorean theorem to find the length of that triangle. So here, a squared plus b squared equals c squared. And we know both the legs. The legs are 23 and 14. So we just plug values in. So 23 meters squared plus 14 meters squared equals c squared. And if we simplify the left side with our calculator, you should get a sum of 725 meters squared. It's meter square because this is square and this is square, but that's okay. To find c square, to find c, we need to get rid of c square by simply square rooting both sides. Square rooting both sides makes c squared to just c, and then square rooting 725 meters square would give us a distance of 26.93 meters. Okay, so the 26.93 meters here just represents the magnitude of the arrow, the length of this diagonal. So let's go ahead and place that in our delta x here. Our delta x here is going to be 26.93 meters divided by 116 seconds. It's the same time as in previous part A. We would just add up all the time. And if we simplify that, we would get 0.23 meters per second. I do want to point out here though, it asks for average velocity and the term magnitude was not mentioned at all. So therefore average velocity is a vector. So what we calculated here, the 0.23 meters per second, is just the magnitude. So you still need to go find the direction, okay? So you cannot just stop here. All right, to find the directions though, the theta that we use should reference the horizontal axis according to the starting point. So here I've placed theta there because it touches the horizontal axis based on my starting point. So if you draw like a little X or a little grid at the starting point, that's what it looks like. Okay, here I've just chosen to go with tangent rather than sine and cosine, only because I know my opposite, I know my adjacent. So by definition, tangent of theta is equal to opposite over adjacent. Here, my opposite based on this angle looking across, that was just 14. The adjacent leg of this triangle is 23. So here I filled out 14 over 23. But then to solve for theta, we must divide by tan or inverse tan on our calculator. So theta is going to equal to tan inverse. So it's important that you use the tan inverse function here on your calculator. 14 over 23. Make sure you use parentheses on your calculator. And then you should get a value of about 31.33 degrees. Okay. So our proper answer for average velocity would be 0.23 meters per second, which is the magnitude, you know, how fast it's moving, the speed. But then you also need to give the direction. And the direction would be 31.33 degrees northeast. Again, the arrow here, without overcomplicating it, you know, is pointing right and up. So right is east and then up is north. So northeast would suffice. Okay, so that's that. All right, so average velocity is a vector, so you need to give the angle and the compass orientation. In this case, be northeast. All right, let's do another one. So here we have an RC car that's moving along this path here shown in the diagram. It says here the straight leg is 8 meters, and then the radius looks like it's given as 7 meters. But to find average speed and then average velocity next. So let's knock out part A. Same process. To find average speed, you would do distance over time. So you need to go find these quantities. Here, the blue arrow that just came up, that is a length of 8 according to the diagram. But it says that it went around this, you know, semicircle or arc. So we need to find this distance, you know, of the semicircle. But that's easy. Semicircle, which just implies half a circle. And then but we know the function for the circumference of a circle or the perimeter of a circle is 2 pi r. And really here is plug and chug. C for circumference, 2 pi I carry down, and r is given in the diagram. Yeah. So the radius here of this semicircle is 7 meters. So I've just substituted r for 7 meters. If you simplify that on your calculator, you should get pretty close to 44 meters. I just round to 44 meters. Okay. But we can't just stop there. Again, this is a semicircle, so you have to take the circumference that you just calculated and you have to divide it by 2. So here I have c divided by 2 because I'm only looking for half of the circle. Half would imply divided by 2. So therefore the circumference we found is 44 divided by 2, which again gives you about 22 meters. And here we know that the first leg is 8 meters, and then we just found that the length of this semicircle is 22. So therefore the total distance would simply be 8 plus 22, which is what I have in the numerator here. So again, for distance, you just add every step or ground that you cover. So 8 meters to the east here, and then you travel, you know, 22 meters along this arc. So that'd be 30 in the top, and then it'd be 2 seconds plus 10 seconds because the diagram suggests that the first leg took 2 seconds and that the semicircle segment took 10 seconds. All right, so it'd be 30 meters divided by 12 seconds, so it reduced down to about 2.5 meters per second. So that is your average speed. Again, no directions needed because speed is a scalar quantity. Let's do part B. Part B asks us to find the average velocity. So all you have to do is kind of listen to these physics function. Delta x is a straight line between start to finish, aka your displacement. But in this case, this one's pretty straightforward because from A to B, it's just a straight line that just came up there. And then to find that distance, that's pretty easy to do. The first part is 8 meters. The radius here is 7. So therefore the next distance over is also 7 because that's also another radius. So if you think about it, you can just do 8 plus the diameter of the circle. Therefore, the diameter of the circle would just be 7 plus 7, which is 14. So in the numerator here, I have 8 meters plus 14 meters for that reason, divided by 12 seconds. So the time interval has stayed the same in both these parts. So therefore, it'd be 22 divided by 12, and then you should get 1.83 meters per second. But you notice here, you don't need to find the angle or anything like that because the arrow that's connecting from start to finish is oriented straight to the right, aka east. So therefore, I need to include the direction. So my proper answer would be 1.83 meters per second east. And that's it. All right. Other than that, stay nerdy. Don't be whack.